name is Doug Sartori, and we are at a Windsor Hackforge event. It's Border City Data. In case you're not familiar with Windsor Hackforge, the way that we are organized, we are a volunteer organization, and we are organized into interest groups. Border City Data is the interest group that is responsible for tonight's meeting. And interest groups are a way for folks to connect over a particular interest or focus on technology. So our focus is on data engineering and analytics. And tonight we are going to be exploring retail data about cannabis in Canada and specifically in Ontario. So just a little bit of an overview. Since the legalization of cannabis in 2018, Statistics Canada has reported an increasing number of data sets that are related to production, distribution, and sale of cannabis products in Canada. In 2018, StatsCan launched a site called the Cannabis Data Hub, which put together 12 different data sets. With legalization having been accomplished, and with regulation on the horizon, Statistics Canada sought to provide some background information for policymakers and other interested parties. So a lot of the data that they pulled together was data from non-cannabis focused sources. They used things like the census or some custom surveys that they put together to be able to report things like the price of cannabis on the black market, the amount of cannabis consumed by people, and so forth. And that was all really information that was helping again to inform the debate around regulation. And what's happened since then is that page has now been discontinued, and I'll just pull up, I'll share my screen for the folks who are online, and I will pull up my, there we go. I will pull up a browser here. So what you're looking at is the archived Cannabis Stats Hub. And so we've got all of the links to the old data tables that were provided. So another example of a table that's been discontinued is that one I mentioned, which was cannabis consumer prices that in the black market. That has been discontinued. Currently available data sets cover topics like the prevalence of cannabis use, the value of cannabis produced in Canada, and household spending on cannabis. And besides these topics, which we're not going to delve into, are plenty of detail on the retail sale of cannabis in Canada. And I picked this information because it's a relatively rich data set. We're going to be able to do a lot with it, but also because it's something that's of interest and it models a behavior that, a motivation that you might have for pulling public data. If you wanted to open a new cannabis shop, this information is really valuable. You can get information about the popularity of different products, where those products are popular, how much money is in the system in each different jurisdiction, and with the data from Ontario, which provides information about cannabis licensees, we can also find out where the stores are. So if you were opening a cannabis store, you might be interested in where are the stores already? Where are the licenses that have been granted in my town? And it would be really cool to put it on a map to understand maybe where there might be an opportunity to put a shop that isn't, in an area that isn't well served. So that's the reason why I picked this data and pick these analyses, because I think that if you are a real world, business person or in some kind of a role where you have to perform analytics, this is the kind of thing that you're going to have to do. So let's take a look at the data that we're talking about here. This is sales of cannabis by liquor and cannabis authorities and other retail outlets, and it is aggregated by cannabis type. So Statistics Canada's website is really nice. It offers, some nice ways to visualize and extract data. So if we look at the ways we can customize this table, we've got different levels of geography. We can either look at the national level or we can look at the provincial level. And we have the ability to choose our reference period. And in this case, this is pretty new data, so we only have two periods, two reporting years, one spanning 21-22 and the other one spanning 22-23. We can also use this little button here, Add Remove Data, to really customize the view of the data. So for example, we might want to look at Canada and the provinces together. Okay, and we can do that. We might also want to, for example, so if you know what you're looking for in the data, you may be able to filter right on the Statistics Canada page the information that you want. Now that would be of interest to us because one thing that we'd like to be able to do, unfortunately, it seems it's not actually an option. You'll know what I'm talking about later. There is a category of cannabis product that we have to filter out because it creates some challenges in our analysis. Okay, you can also select the reference period. So there we go. So I've pretty much changed that that table right up, and now you can see a far more expansive view, lots more information. On StatsCan table pages, they will typically offer you some information about the data source, related data products, and also if you're doing this for a project at school, they are kind enough to provide you a citation so that you know how to cite this page, this data. But what we would like to do here is actually download the data. So we can click this button on the StatsCan page, download options, okay? And you have a whole bunch of ways that you could download it. One that is really attractive is download as displayed, because you can customize your view on the Statistics Canada page, look at the results, and if you're fortunate enough that in your application, what you're looking for is is a representation of data that you can create with that table customization tool, then you can download that CSV just as it's displayed, and you've got something that you can present right there. We're not going to make it that easy on ourselves. And the way that I recommend usually consuming data from Statistics Canada, if you're downloading a CSV, is to look for the version that is for database loading. Okay, so let's grab that file. Actually, I already have a copy of it, but let's just open that up. Okay, what are the odds that Excel will, yep, there we go. Okay, and here's what that looks like. So here's what our data looks like. Because we chose the version of the CSV file that represents database loading, that means that we get one row per data point. And that's really valuable because this is a very unopinionated representation of our data. We don't have to worry about the way that it has been aggregated or pick apart or extract anything from a tabular structure. What we have here is one row in our CSV document that matches up to one row in a database or one row of our data. So one way that we can work with this is right in Excel, and Excel, I'm sure everyone has at least seen or heard of Excel. For a data professional, Excel is an absolutely essential tool. There is an awful lot that you need to do with a tool like Excel, where you can basically open a file, manipulate raw data, examine raw data, and we can even do some preliminary analyses and generate some charts just from this file that we have here. So what we would do is, in this case, we could create a pivot table, and the database loading CSVs are fantastic for pivot tables. because again, that data is really structured in an unbiased way. And now by using the pivot table, we can query that data in a way that, in a similar way to how we will query it later with a database. So in this case, let's see. Okay, so on our rows, let's put the geography. Okay, try that again. Welcome. So we'll put geography here, and there we have the provinces of Canada and Canada itself. Okay. Then we can drag into our rows. Let's do it this way. Let's do columns for our periods, so we can look at data for each period and then a total. And then what we would like to do, I think, is we would like to look at the actual value of cannabis sold in each of those different geographies. So if you look back at our raw data, you'll see that we've got a column named value, okay? And then we've got a column named value. So I don't know why they produce the data in this way, but they do. We have a duplicate column names. So in our pivot table, and you'll see later SQL Server as well, are both smart enough to not let us shoot ourselves in the foot this way. And so that second value column is named value 2 in our pivot table display. So I'm going to drag that down to values, and there you go. So in about 5 minutes, we went from looking at the data on the Statistics Canada page to having something that we could look at and evaluate. So there's a couple problems with this data. One problem here is that we are definitely double counting, because we have Canada, which is a summary of all geographies in the same data table as each province. So what we'll have to do is add a filter. We can just drag this geo column down to the filter area, and we can, oh, I can't have geo in both. Well, dog my cats, how are we going to solve that? Let's see. I guess what we could do in this case is, one way that you could deal with that is to go back to your data source and filter out that data. We could just delete the data from our Excel spreadsheet. And so this, I hope, is giving you some inkling of what the value of exploring your data in Excel and using a tool like a pivot table, what the value of that is. We figured out pretty quick that we have a double counting issue in our data. So we're going to have to work with our data to solve that problem. So the easiest way to deal with that is just delete those rows. Just delete those rows from the data and see what that does to our pivot table. Do we have to refresh this? Is that how that works? Yeah. There we go. No more Canada. And if you remember what the total of the value of cannabis sold was in Canada, you'll see that our grand totals now line up with those row totals for Canada. So now we're in business. And of course, from here, you could also generate a chart. So let's change up the representation that we have in our pivot table. Where's my pivot table tool there? There it is. So instead of doing it this way, why don't we look at the type of cannabis? Okay. I think that's probably more information than we want in this analysis. So there we go. Now we have the national value. This is summarizing all geographies, because our pivot table doesn't have any interest in geography. That's not a column that we're looking at. We have the total, the national total of sales by type of cannabis product. And from here, we could take this data. So what I would typically do is I would take this data, because I don't want that total. I would take it and I would pop it into a new sheet. And then from there, we can we can chart it. Let's do a pie chart, a nice simple 2D pie. And here we go. We've got a little chart that's showing us the distribution of cannabis types and how popular each type is. So unfortunately here again, we have total cannabis products in our result set. So that is a total that we want to get rid of, because that is not, let's shift those up, sure, what's the difference? There we go. Now we have a true representation of the popularity of different types of cannabis, and you can see that dried cannabis flower is the gorilla in the market. This is the vast majority of the market, followed by inhaled cannabis extracts, which is the second most popular type of product. So we've got some visualizations, we've got some data. You can see how easy it is to use that pivot table to kind of move that data around and get different representations of data. And Excel is so fluid. It's such a blank canvas that you can do things like this. Grab a chunk of data that you want to represent, generate a chart. So if, for example, you were writing a report, you were writing some kind of a report document that you intended to share with folks, this might be where you stop. You can use Excel to work with this data set. You can figure out how you want to represent it, generate some charts, copy and paste those graphics into your report, take some numbers and put those into your report, and you're off to the races. A lot of data analysis works this way. And the reason that a lot of data analysis works this way is that it's highly efficient. If you just need an answer, or you just need to generate a chart to visualize something that's happening, you can do this in a very short time. I think we've spent all of 20 minutes getting the data and visualizing it. So this is a great place to start, and it may be a place where you just stop because this is all you needed to know. Okay, so one thing that I wanted to mention about our let's see, how easy is this to do? We're going to nuke that out of there. We're going to put back the geography. One thing that you might notice when you look at this representation of data is that in both periods, the Northwest Territories and Nunavut had goose egg zero retail sales. So I did look into it. I'm going to be reporting on this for a podcast later this month. So I did look into that because it's kind of interesting. You might want to know that as of today, there is one licensed retailer in Iqaluit, and the Northwest Territories now has 6 stores licensed for cannabis retail. So presumably in future years, those blank spaces will fill up. So that's Excel. And that's one way to work with this data. So let's look at some of those same analyses, but instead we'll load this data into SQL Server, which might sound a little bit intimidating, but it's really not. So I happen to have SQL Server installed on a Docker container in this building, and I've created a database called Cannalytics for tonight, and we've actually already loaded the data. But I'm going to show you how we can do that. So there are 2 tools that you can use on your desktop to work with Microsoft SQL Server that are both provided by Microsoft. What we're looking at now is SQL Server Management Studio, which is some kind of a fork or variant of Visual Studio, which you may be familiar with. It's a very popular IDE for developers on the Microsoft platform. And you also have the newer product, Azure Data Studio. Azure Data Studio is a more modern product. It doesn't have all the capabilities of SSMS. Management Studio has been around since I started in this business when I didn't have gray hair. So it's been around for quite a long time, and a lot of functionality has been added to this product over the years. You can do a ton with SSMS, Azure Studio is catching up, and it has some terrific capabilities, including a plugin architecture that allows you to extend your Azure Data Studio experience, but it's not quite there yet in terms of offering the full breadth of functionality. So having said all that, we are going to look at our database. And one of the things that we can do with SSMS is we can import data from a flat file. And that brings us to the lovely flat file wizard. I want to show you this, and then I want to show you the other option that you have. So data, okay. Click next. We get a nice preview of what our data will look like, so we can preview it. There's a checkbox here. Use rich data type detection. We're going to turn that off because this is a pretty small set of data, and we're going to review our options manually and determine what typing we're going to use. So I don't particularly think we need that in this case. So let's click next. Okay, so we've got some really bad guesses here from SQL Server in terms of what the data types of these column values would be. It's not surprising that SQL has a hard time guessing because a CSV presents all the data as either strings or numbers. I think that the CSV spec tells you to either enclose the data in quotes if it's a string, or leave it bare if it's a number. And that doesn't give SQL a whole lot to go on. There's a little bit of inference happening here in terms of the potential length of the data field. You can see that SQL has analyzed some rows of this file and figured out that it can use a one character long string for these two columns. And the varchar 50 or the nvarchar 50 data type is essentially, that's a Unicode string with a maximum length of 50 characters. So that's what that means. One of the main differences between relational databases and tools like Excel is that relational databases are strongly typed. When you create a table to store data, you have to identify exactly what kind of data and what length of data is going to fit into that column. This is important. This is one of the main ways that we prevent data anomalies from getting into a database. If we can identify up front what are the acceptable types for this data, and the more strict we can be, understanding what our data looks like and what kind of values may live in that particular column, the more tight we can be in terms of specifying our types. So for our purposes, most of these can stay as an nvarchar because we don't particularly need to do a whole lot with them. One thing that I know from repeatedly doing this exercise is that the import wizard has completely guessed wrong here on the coordinate column. That has a format like 1.1.1, 1.1.2, etc. And it, for whatever reason, it fools the import wizard into thinking it should be treating that data as a date time type, but it's not. So instead, we're going to change that into an nvarchar, just like everything else. And these short length columns make me nervous. One of the things that will happen to you when you import data is that any data anomaly, any anomalous data, any data in your CSV that isn't going to fit into that data type is going to cause an error. Now you can control in importing, although it looks like not as granularly as you can using the more generic import tool, but you can to some level control what happens when an anomalous row is encountered, or anomalous value is encountered. The best thing to do is to not have anomalous values. So one defensive way that you can do that, we're not going to do it tonight, but one defensive way that you can do that is use nvarchars for every column in your import. This is a trick that you'll see folks do. Bring it all into your database, and then transform the data from there into the data types that you want to use. That is often a way that SQL practitioners will do an import in those two stages from CSV. And the reason is that it just makes life easier. We're query writers as professionals. We understand the database. We're comfortable manipulating data within the database. So, it's even though it's two steps, it's often better than being frustrated by having to go through this wizard over and over and over again, trying to get that magic mix of data types for your file. And when you're automating data imports, that becomes even more critical because most likely you have a less awareness of what's in that file. If you're importing data in an automated way, you're probably going to encounter a lot of errors. So this is one of those choices that you need to make as a professional. Where do I want that error to land? Do I want that error to crap out my data import? Do I want to bring in the data and then subsequently discover that error? Where do I want to deal with it? So it can be a little bit frustrating, especially if you just need to get the data into your system so that you can evaluate it. Okay, so we know that value 2 is actually a big integer. It is a numeric value, but there are no decimals, so we would want to use an integer type there. And I don't think that we need to worry about anything else. So we're going to give this a try. Let's hit the finish button so that it actually does something. There we go. Success. Okay, so our import worked. The other way that you can do this, and I just want to be complete. So we have the flat file import wizard, which is very specific and focused on importing CSVs into the database. It's built so that it's easy to use. It doesn't really give you a lot of options. It doesn't expose a lot of nuance, but it's also, it's way simpler for a very common use case. The data import wizard, on the other hand, here we go. The data import wizard is a little bit more intimidating, but it's also much more flexible. And one of the ways that it's more flexible is that it has multiple options for data sources. So rather than being stuck with flat files only, we can grab data from a variety of sources, other databases, Microsoft Access included, Excel. You can use Excel as a data source for this sort of import, as well as flat files. And when we choose a flat file, so you can see that this is looking pretty different from the import wizard. It's essentially the same process with just a few more options. So I'm just going to leave this at this screen, and I just wanted to let you know there are a couple of ways to do it. But this is more or less going to be a similar workflow with more advanced options, more flexibility. You can do things like change the column names in your target table, that sort of thing. Again, specify exactly what you want to happen when an error or anomalous data is encountered in a particular column. All kinds of nuances that you can't control in the text or the delimited file import wizard. Okay. So we have two tables now. We have the table we just imported, which we're just going to throw away because we already have a nicer version. Okay, we have one with a nicer name. So we're just going to nuke that. And let's take a look at what is inside cannabis sales. So what I'm doing now is just not sure what the experience level is of folks in the room and on the call. I'm writing SQL. SQL. SQL is structured query language, okay? Every relational database vendor will use their own flavor or adopt someone else's flavor of this language. So Microsoft uses TSQL, that's T-SQL, that's Transact SQL. It has some capabilities over and above the SQL specification. When you, the American National Standards Institute are the ones who specify the language. So you will hear people talk about ANSI SQL. That's the generic sort of center of the Venn diagram minimum set of capabilities of a database. And if you're entering, like if you're just starting your journey working with relational databases, all the popular ones are good. They all have their niche, they all have their value, and probably the most important thing in terms of which one do you work with is which one is your employer standardized on, which one is, which one is the one your client has specified, et cetera, et cetera. But it is important to know that that the SQL language you learn on that your first relational platform is going to have its own extensions, its own unique stuff that is not necessarily part of ANSI SQL. So when you go and look at another relational database system, you'll be in for a little bit of culture shock in terms of syntax and the way that you achieve certain tasks and so forth. Not a huge deal as long as you know that that's the case. Just especially when you start to lean on those special capabilities of the language that is on your relational database system, you want to know that you're learning something that's unique to that platform. One good example of that is the geospatial extensions in SQL are very different, for example, from the geospatial extensions in PostgreSQL, which is another leading database system. So if you're working with geographic data, that's a particular area where you'll find each of those systems is different. So pretty much the most basic SQL query is select star from our table. So the asterisk or star here represents all columns. So what we're looking at, just to give you a kind of a very brief overview, I don't want to bore folks. I know there are some professionals on the call who are SQL experts, but what we're looking at here is we have the select statement, and then we have our select list, which in this case is a wildcard, but it can be a list of columns separated by commas. We have our from clause, which indicates what data source that we're working with. And we'll stop there and we'll add a few clauses as we go along. Okay, I'm in the wrong database. Go, what is, okay. Here we go. That should look familiar because it is the data that we just pulled in. I see a lot of nulls in those 3 of the last 4 columns. Oh, and some null values. Let's take a look here. What is this? Oh, interesting. So we've got something to be aware of. We've got some null values in our value column. So why does that matter? Nulls are not zeros. A null is not a value. A null is a marker to indicate that there is no data there. So it's really important to understand the difference between a null marker and a value in a column. That null is going to have different behavior from a zero valued piece of data. Okay, if you run an aggregate on like a sum or an average on a column and your data set includes a null, you're going to get a zero back. Yeah, you're not going to get data back. So you have to be prepared for that. And if you know that your data might be dirty in this case, so there's a couple ways we could deal with this. We could just clean it up. We could just clean it up here for our purposes. For our purposes in that column, a zero and a null have the same meaning because we know that this column to us represents the amount of sales in a geography. And it may be that to the reporting organization, no data has a distinction from zero. But for our purposes, we can't do anything to aggregate no data with numbers. So for our purposes, that might as well be a zero. That's an example of why it's important to understand your data. You can, of course, when you create a table, you can specify that a column can't contain a null value. If your understanding of the data that you are going to be storing in that table includes the fact that this record is not a valid record without the data in this column, then you can specify that that column cannot contain a null value. We didn't do any of that sort of thing. We didn't even create our own table. We let the import wizard create a table for us. This is not what you would do in a professional setting. In a professional setting, you may well use an import wizard to bring data into your database, but generally you want to craft your database objects that are going to be persistent. You want to craft them with a little more care than that, and you would create a table. For example, if we were creating a database to store this information, and we were going to store it for the long haul, we would be carrying forward, in this case, a whole bunch of information that we don't care about. We don't care about the coordinate. That's data that matters to Statistics Canada. It matters to some of their partners because they report it. It doesn't matter to us. The unit of measure is probably something that we can safely not include in every single row of our data. Et cetera, et cetera. So, these columns don't contain much data at all. So we could really slim down our data if we were storing this for the long haul, and that's the way to do it. You don't want to have all kinds of cruft in your database. The only thing that it does is it makes your database bigger than it needs to be, and it makes it harder to do the analyses that you need to do. You'll have someone downstream of you who's looking at this table and asking, well, what is vector? What is vector, and what am I supposed to be taking from that? How does that influence all this other data? When the truth is, like, I loaded this data. This is my database. I don't know what that is. So it's not information that matters to me. It should be removed. But again, this is just a temporary table for the purposes of mucking around. So I'm not going to worry too much about that. But that null value is going to be an issue. So before I get into more complex queries, let's just take a look at that. So let's see, how about sales? There we go. And we're going to add a where clause here. And so the where clause is the way in a SQL query, and let's just separate it appropriately. The where clause is how you filter at the row level, how you filter your data. So we will specify a column. In this case, it's value2, and it's value2 in all caps. And so here you can use a number of different operators. Just as in any programming language, you could use the equals operator to specify, if we wanted to know where the value equals 0. You could use the does not equal operator to find, anything but a specific value or a set of values. You can specify a range of values that you want to match using the in clause, 1, 2, 3. You can use the not in clause to do the inverse of that. Lots and lots of things that you can do with the where clause. But in this case, we want is null. We want to know, where is that data null? Again, null markers aren't data, and that's why we don't use an equal sign. We are not using the equivalence operator here. We are using a separate operator, which is used to identify null markers. So here we go. Okay, we've got a lot of them. So we have, it looks like, yep, there's our Northwest Territories and Nunavut with all of their nulls. Now, based on what we know about the number of cannabis stores, that we've only recently got some, it's very possible that those represent zeros, but they might also represent Nunavut and Northwest Territories didn't report in time. They didn't get their data in time. We just don't know. But we're going to guess, which I don't recommend doing if your job's on the line, but nobody's job is on the line here. We are going to just update that. We are going to update cannabis sales. So now this is a different kind of query. Instead of asking SQL Server to return a set of data for us to look at, we're telling SQL Server to make a change to some data. So we provide the update keyword. You know, I keep doing this, and I'm just going to stop and talk about it. I keep capitalizing my keywords, and that's because I'm old. Once upon a time, the standard way of composing SQL was to use all caps for keywords. This is because we wanted to be able to visually see the difference between our keywords and our data and our values, etc. And because SQL is case insensitive, we could just all caps it. Almost nowhere are you going to be looking at SQL code that's not syntax highlighted. So you don't have to be like me. You do not have to have the muscle memory of making these keywords capitals. I promise you don't have to do that, but I'm sort of stuck halfway in between. Okay, so we have our update statement, and we are going to set value 2 to 0, and then supplying the where clause. So what this query will do, it will update the table cannabis sales. It will set the value 2 column to 0 anywhere that value 2 is null. One horrible mistake that every practitioner sometimes makes is forgetting the where clause. And if you write an update statement and you I hope you like a 0 in every column in your data, right? Be careful and make backups. You can make backups, of course. SQL Server has its own backup facility, daily backups. Your system administrator should be taking care of all that. But it's pretty easy also, assuming you have a healthy amount of space in your server, to do things on the fly, like backup a table. Just duplicate a table within the database before you do some risky operation. These are things that you kind of learn to do because it's a lot faster than going through the process of recovering that data if you mess it up. One other thing that I know a lot of people swear by is you write the where clause first always. You write your where clause first, and then you fill in the dangerous part of the query. It's up to you how you handle it. Just know that there's a danger there. Okay. So SQL tells us we have 58 rows affected. So now if we go back and we ask where value 2 is null, we get nothing. We get an empty result set because we have fixed that. We've updated our data. We've made a modification to our data in place with a query. So now we'll scroll quickly through here, and you see nice clean data. We've decided what those nulls meant and imposed it on our data, and that means that now we can do some more analysis with that. So you can use SQL for casual analyses, and in fact, with large data sets or with complex data sets where you're going to have multiple tables, it's really the only option. As soon as you start to have to take data from 2 different sources and combine it, Excel is going to become a harder tool to use, and you're going to want to have a tool like this. So is the power and capability of the SQL Server engine being underutilized in an analysis of a single table of data? Yes. Is it a good idea to use this tool for simple tasks so that you can you have some facility when you face a task that you need SQL for? That I would suggest it's a good idea. Okay, so I've pre-written the code. So my fingers are going to fly really fast here. We're going to now supply a more complex query so that we can get something like that pivot table that we had. So we'll create a more specific select list. We definitely want the geo. Okay, and we're going to do the type of cannabis. So let's do first we'll do an analysis just like that pie chart that we generated. Okay, now we have a problem. Our values for 21, 22, and 22, 23 are all in the same column. So we can't just simply sum up that column and get a total. So what we can do though is we can use some capabilities of Transact SQL, and I think this is ANSI SQL actually. I think this is universal to filter data in a column. Okay, so we'll use the case statement for that. We're going to nest a couple of functions here. We'll start with the sum function because we need to sum everything. There I go again. We need to sum everything up. And then we'll use a case statement. So the structure of case is case when ref date is, okay, 21, 22. So that's our date, and we've got that value there. You could copy and paste it if you want to be sure, but I'm pretty sure I've got that. When, then, value 2, okay? 0, and. Okay, so this is a SQL case statement. So what we're doing is we are evaluating the data in every single row in that column. So when the reference date is 21, 22, we want the value to show here because this is going to be our 21, 22 sum column. And when the ref date is not 21, 22, use a 0. So that way we can sum up the whole table's data and only get the values that we're interested in added into this sum. And we'll close our bracket, that bracket around the sum function, and we will name our column. When you output data from SQL by query, if you don't specify an alias, you'll just get the column name. But if you create a little structure like this, some kind of function or some kind of work that's happening, this construction doesn't have a name until we give it one. So we do want to specify those. Okay, and then let's do the same thing. Paste. Let's do the same thing and get 22, 23. Okay. There you go. Okay. So that looks pretty good. Let's see what that looks like. What? Oh, I don't need to cover that. Okay, we got an error. Why? Because we're summarizing data without telling SQL Server how it should be aggregated. So we have aggregate values in the select list, and then we have non-aggregate values in the select list. And SQL Server says, well, this doesn't make sense. I can't do that. So we have to now add a group by clause. So we are going to now tell SQL by providing a list of columns. We're going to tell SQL what columns do we want to aggregate this data by and in what order. So we will group it by geo and type of candle. No, not type ID. Type. There we go. Okay. Okay. All right. And now we've got an output that's showing us something that's not too far off from our pivot table. Here's the geography. Here's the type of cannabis. And then here's the value of sales in each of our 2 years. We can do things like we could add a column that sums it up. That would not be so easy with this representation of data because the rows containing 21, 22 data are separate from the rows containing 22, 23 data. What I would probably want to do is transform this data into some alternate format, either into a table and save it, or by using a tool in SQL to create what you might think of as like a virtual data source, like you can use a common table expression, or you can actually you can use a query as your source rather than a specific table. There's a lot of elaboration on these basics that you can do. There's a ton of power in this language and this database engine, but that's just some tastes of what might be possible. So one thing that we aren't doing here, though, is we're not filtering out what we know is are duplicating columns. We have, or are duplicating values. We have total cannabis product, which is just straight up going to be the sum of all other cannabis types. And then we have the Canada geography. So we're going to add a where clause here. And we're going to say type of cannabis is not, now here I'm going to copy and paste. Okay. And because we want to make sure it's both, geo is not, okay, I'm pretty sure I can spell Canada. There we go. So now we are specifying, and let's do this a little bit more nicely. There we go. I would say there is not really any standard indentation or coding style for SQL. I've seen a lot of different shops and I've seen a lot of different approaches. I like to structure it like this. You can kind of get a sense of what my coding style in SQL is. I like to be able to see what's going on, and I'm very happy to trade vertical space for clarity. I do what you want. It's pretty easy. We've got lots of tools now to reformat SQL, so you can come up with your own approach, and it will still be comprehensible to others. The only thing that I strongly recommend is that you do impose some kind of structure on your SQL code. It can feel great to just write it all out in one line, and I've seen people do that. It feels great to write. It's awful to maintain. Don't do that. Have an opinion and put some structure to your code. I highly recommend it. So we filtered out our cannabis type that we don't want and our geo that we don't want, and just in case I haven't run it, and now we have a nice little output. I'll just pull this up a bit. A nice little output that we can do what we want with. So you might present this. You might present this in an application to an end user. You might compile this into a report to present to an end user. You may use some external visualization tool to present this data to an end user. There are a ton of ways to connect to SQL Server, and there are a ton of ways to visualize data with it. So the other thing that you can do from here, just to go completely full circle, is we can copy this data with its headers, paste it into Excel, and we've got a spreadsheet of our data in the shape that we want. And that interaction between Excel and SQL is, it's a pattern that I use quite a bit. You'll produce some intermediate data set, you'll futz with it a little bit, you'll move it over to SQL, you'll do some queries, maybe you really want to see what that result set might have in it, and so that might be easier to take this to Excel and do some exploratory work with a pivot table. The two tools are complementary, and in your own workflow, in your own world with your own data, you will figure out what the right balance is. So that's kind of the data import and analysis on the desktop piece. So I'm just going to stop there because I've talked for an hour, and I'm going to ask if anybody's got any questions, or is there anything that you'd like me to talk a little bit more about, or is something you'd like me to demo here? Sure.
What was what did you say about the is null? The null. Why are you putting is?
Okay, because a null is not a value, it needs a separate operator. So there are operators that work on null markers, and there are operators that work on values. Okay. Just like you would in a lot of programming languages. The way that you test equivalency of strings is different from the way that you test equivalency of numbers.
Okay. What happens when you put an equal?
The query will crap out. It'll say it doesn't make any sense.
Another question.
Sure, go ahead.
So I was wondering if you could just quickly show again on the Cannabis Stats Hub where you found the table and
okay.
you download the CSV.
Okay, sure thing.
Yeah, I got lost from there, but everything afterwards I got like one.
Okay, and Mackenzie asked a question in the chat, and just before I show that, he wanted to know, are T-SQL and MariaDB the same? And I think that this is worth taking a minute to talk about, just because this is it's pretty easy to get mixed up in, especially when you're getting into a new area of technology. You know, is that a language or is that a platform? And sometimes the language and the platform have the same name. So it's a good reminder that you want to be cautious when you're exploring a new technology, and make sure that you understand the kind of the basic concepts of what you're working with, and understand, like, are you comparing apples to apples? Mackenzie, it's a great question, because if you don't ask questions like that, you can end up having misconceptions in your head they'll produce errors in judgment, and that's not good. So it's a good idea to ask those clarifications. Okay, you wanted to see the data again. Do you want me to put this into do you want me to send you that URL?
Sure, if you put it on the chat, that would be great.
Okay.
And everybody online can get it.
Okay, fantastic. I'll do that. Okay.
Thank you.
Yep. So that is the data source, and I've got two different visualizations that I want to show you. So one visualization is a tool called Observable Notebooks, and I love this tool. I use it all the time. It's a great tool for. Bring it over here. No, it's a web-based platform. Yep. Okay. So just like a quick look at Observable, this is my page. For those who don't know, I do mostly monthly podcast called Mean, Median, and Moose. All of this that we're talking about today is going to be on the podcast this month. It is April, so it's a good time to talk about this stuff. And I tend to generate some visualizations. There are multiple panelists on the podcast, and we each bring our own data set and our own visualizations every month. So you can see that there is just from this preview screen, you can see there's a few different types of visualization that we can do. We've got a heat map there. We have a couple of bar charts. We've got some line graphs with a lot of really interesting properties. We got a map. You can do a lot with these. So Observable is something that if you have a use case where you need to share analyses publicly, or you want to share analyses publicly, Observable is a fantastic tool for that. You create Observable notebooks with a combination of text and visualizations here. I was kind of proud of this one because I made it into a little article, so I'll just share this with you guys so we can look at it together. This was something we did on old data and discontinued data, and it is a little bit of a description and some charts showing information from the first census in Canada back in 1664 or whatever. So yeah, kind of neat. And you can include things like a visualization of or a table visualization that lets people do their own filtering and like kind of exploration of the data, as well as canned visualizations that you create yourself. So pretty nice, flexible tool, pretty easy to get into, and it doesn't cost anything. So I highly recommend creating an account and playing with Observable if you think that that's your use case. So there are lots of really popular tools for data visualization. Power BI would be one that's really popular. Tableau is another one that's really popular. These are great for connecting to live data sources. If you have a database, a relational database, Power BI or Tableau may be the tool that you reach for. SQL Server reporting services in Microsoft SQL is a product that ships with SQL and can do a lot in terms of tabular reporting. If you want to serve up reports to people in an organization and you want to be able to kind of organize them in one place and let folks save reports or schedule reports and all that stuff, SSRS is a really great tool, and it's part of your SQL Server distribution, so that's worth looking at. In this case, observable is great for taking a slice of data and putting it in isolation so that you can do you can generate these little bite-sized visualizations and data exploration tools and put them out on the web to share. So it's a little bit of a different use case. I find that when folks try to share Power BI and Tableau stuff on the public internet, it's a little clunky because it's not really what it's for. You know, what that's really for is sharing information within an organization, or being able to present a dashboard to the bigwigs at your company, all that kind of stuff. But observable is really for well, what I do on Mean, Median, and Moose. Taking a piece of data and exploring it in a way that anybody can look at. And then the best part of observable is that all the code is visible all the time. So if you see a really cool notebook that has a visualization that you want to use, you can look at the code and try to figure out how to import it into your own code, into your own notebook. And over the years, I have done an awful lot of that. My Mean, Median, Moose colleague, John Haldeman, is a way more of a whiz with JavaScript than I am, and he's done some really cool stuff, and I've come along behind him and copied and pasted his code, and I can do that because these tools are all public and the code is public. So with all that being said, I am going to first, I can just open this up and we can take a look at it. So what are the steps? The first thing that I had to do here is I added a file attachment. Okay. So there's a couple of different attachments here, but you basically just upload the file. And once you do that, it becomes available in the notebook by addressing it with this I guess, file attachment class method. And we're assigning that to a variable. And now every other cell in this notebook is going to be able to consume the data using that name. And we can also expand our data and just explore it here in its format. So what's happened here is that we've told observable that we are looking at a CSV file. And so it's gone ahead and turned that CSV file into simple JSON objects that we can manipulate in our JavaScript code. Okay, this cell is a mistake. I was messing around with database connections. So you can connect, I was just kind of trying it to see what it would be like. You can connect observable to a database. You can connect it, you can import a SQLite database right into your observable notebook, or you can actually connect to a data source, an Azure data source, or even create a connector. I was looking at it, I was going to do it, and then I decided that we had enough on our plate for today. But you can connect even to an internal database. What happens is you run a little proxy tool on the command line on the internal system, and observable can talk to it. I don't know how a good idea that is for a production system or anything, but it's an option. So then here we've got a tiny little bit of code using what's called observable plot and generating a very, very simple, quick bar graph just showing the distribution of cannabis sales. And again, you can see we've got that problem with our data, so we're going to have to do some cleanup. I'm going to have to do some cleanup before I post this anywhere. This has got to go, but here's the distribution of cannabis sales over the 2 years across Canada. And it's just a tiny little bit of code here to generate that. And just to give you a let's see, there we go, observable plot. Let's just take a look at what you can do with observable plot. And here is some examples. I don't want you to be limited in your concept of what can be done with this tool by what I did in 20 minutes. There's an awful lot of really cool visualizations that can be created with observable with a little bit of effort and a little bit of research and a healthy dose of copying and pasting from other people's tools. But all of these examples are notebooks that you can open and look at. You know, you could look at this Simpsons IMDb ratings, okay? You could look at this plot because maybe you want to create one for, I don't know, Star Trek episodes, and it would be really cool to have this exact same visualization. Well, here's the notebook. And there's the source data that they've got from IMDb. So you can examine that data and then massage your own data to fit that format. And Bob's your uncle, you've got a visualization. You can play with it from there. And you can see that the amount of code required to generate a pretty nice looking graphic is not very much. You're really just limited by your capabilities, what you can do, which is why mine looks like that. But again, I wanted to make sure that you had an opportunity to see the wide variety of cool things that you can do with Observable. I love this tool, and I can't recommend it enough. Okay, so that's Observable. I hope that I've given you enough of a taste of that to get you interested in it. And I've just got one more thing to show you, one more way to visualize data. And it goes back to what I was talking about at the very top of this discussion. And that is, imagine that you are planning to open your own cannabis shop, and you want to know, well, where in Ontario should I open a shop? You know, I'm going to apply for my license. You know, where should I be shopping? Where should I be looking for space? All that stuff. One way that you could evaluate that, you know, and come up with an answer is to create a map and look at it for yourself. So the Ontario is, again, the regulator for cannabis in Ontario. So we take a look at the AGCO page, okay, and we go take a look at their data inventory, and you will find AGCO page. So what you've got here is a searchable tool that allows you to look at basically the location, the name, what municipality it's in, and the application status, okay? Handily, you can also just grab a CSV. Let's open that up in Excel too and take a look at it. Okay, so nothing to write home about. There's not a whole lot here, and the problem is that this is not enough for us to create a map with. What we've got here is a list of municipalities, store names, and addresses. You cannot plot this. You cannot plot a text-based address on a map. But what we can do, at least not reliably, what we can do though is we can go to the internet and we can use a tool. There's a ton of these tools, but this is the one that I use for tasks like this. It's free. It's called GeoAppify. Paste that into the chat as well. And they are a vendor of geocoding services, but they also offer, you know, casual geocoding like we're doing here. They offer that for free. So you can upload a CSV file, and I'm going to do that. Well, it looks like we are going to have to do this the hard way. Okay, so I'll keep that in mind, which means we're going to end up with a little bit of a messier output, but that's okay. It will show you what we're looking at. So here we go. We've got that Excel file that we just downloaded. That's in our Cannalytics folder. So we can upload that by dragging it over here into our GeoAppify. Okay. So what are the columns that should be used for address search? We absolutely need the municipality and we need the address. Okay. So what we're telling GeoAppify is this column has the address, this column has the city. And the reason that I recommend GeoAppify and that I like to use it is that they use multiple geocoding services and they give you back a result. They don't just give you latitude and longitude. They also let you know the confidence level that they have in that result. Like, did we have 50% of the data we would normally use to make the call, 30% of the data we would normally use to make the call? And you can use that to kind of improve the quality of your geocoding. And depending on your data source, you're going to find that your geocoding works better or worse based on how easy it is for each geocoder to interpret the address of that data. So let's give it a try. This is going to take a few minutes, so I probably should have done a lot of talking while it was going. We'll let it run. So we'll GeoAppify will use OpenStreetMap, OSM. It will use other tools, and what I've found is that if you are precise about the location, it will be pretty good. There are not a lot of there's not a lot of consistency in the way that people identify addresses in rural locations in Canada. So I find that that's where you really run into problems. You know, Road 2, there are a lot of Road 2s in this country. You know, Road 2 Harrow, or you know, Highway 17, or you know, something -71. These type of things are they're not easy for the geocoder to interpret. So rural stuff you want to you definitely want to keep an eye on. And maybe what I'll do is just, while we're geocoding, is I'm just going to open up QGIS and give you a bit of a look at that in anticipation of this data being geocoded. QGIS is a geographic information system. You may have heard of ArcGIS. That's the industry standard. ArcGIS would be the Microsoft Windows of GIS data manipulation and visualization tools, and QGIS is the open source equivalent. It's the GIMP to Photoshop. QGIS would be that. Right? It's the open office to office. That's what QGIS is. And it's compatible with ArcGIS files, and it offers a lot of the same functionality. So when you open up, here's a few projects that I've done recently. I did a pizza map, and I did a nice little map for a friend's Jane's Walk so that they could have a nice visualization that was for kids. So QGIS allows you to bring multiple layers of map data into one interface and then visualize them together. You can also join those layers so that they can interact with each other. While we're waiting for that data to geocode, I am going to show you how we are going to get a base map. There's a couple of ways that we can do that. One way that is pretty fantastic to get base map data is to use a plugin called QuickOSM, which queries OpenStreetMap. OpenStreetMap is the Wikipedia of maps. It is the open source world map at increasing levels of detail and granularity that is maintained by a community of volunteers. We have an OSM interest group. If you're interested in GIS mapping and that sort of thing, Lauren Hedges, who's the managing director of Hackforge, runs an interest group called OSM Windsor, something like that. And every month they do OSM related stuff, mostly focused on improving the map of Windsor. So that's a cool tool. I'm glad I had a chance to mention it. What we can do with QGIS and OSM by using QuickOSM is we can do something like, okay, Windsor, Ontario, and then pick a key. Let's say we want roads, just roads, okay? And then there are sort of subcategories. They call them values. It's a key value pair, but it's really a category and a subcategory of data. So these are all the different street types. If we just say everything, then we can just run the query, and what we will end up with here is a street map of our city. Okay. Okay, so this is one way to get base map data. What it's done is it's brought in 3 layers, one layer for multi-polygons, one layer for points, and one layer for lines and line strings. So in our case, what we would want, if we were visualizing on a street map of Windsor, we would want to look at something like that. In a layer, you will have an associated data table. Okay, let me drag that over here. So here's the associated data table with that QGIS exported data. There's a whole lot of information here, most of it null, but here we go. The name of the street is there, and in some cases, the speed limit. So this is something that a volunteer would have had to do. A volunteer somewhere, some wonderful OSM volunteer has let the world know that Mount Royal Drive has a 50km/h speed limit, and EC Row has a 100, but everything else is blank. So there's obviously lots of work still to do. But that's what the data representation looks like. And so you have a table of data associated with map data in QGIS. Okay, that's what we're looking at. So that is one base map. That's not the base map we're going to use, but I just want to show you a couple of options. So let's remove all those layers. Okay. And we are going to add a layer for real, though. A lot of different ways, a lot of different types of source data. You'll see SQL, PostGIS, lots and lots of different kinds of data sources, including ArcGIS servers, and file-based vector and raster layers. So we'll start with adding a vector layer. Okay. And we're going to need to find that, and we know that that is in our Cannalytics folder, which is over here. There we go. Okay, I got this from, this would be a Statistics Canada base map, and this is the base map of the country, showing only the big picture political boundaries between provinces and territories. So I guess I have to grab that locally first. And what we're looking at here in this folder is the components of a shape file. So we have the shape file itself. We have the project file, which is very small, just contains some parameters of the project overall. The DBF file, which is a DBase3 database, that's what contains that's what the attribute table stuff is contained in, and an index file, which just makes access to different components of the shape file faster. So there we go. We've got our source data set, and in this case, we are just going to add that guy. And what comes up, as soon as you start working with maps, you are going to run into coordinate reference systems and map projections. Okay, there are so many different combinations of coordinate reference systems and map projections, all designed to serve specific purposes. So Statistics Canada uses a projection, and you can see in that little visualization there that projection is focused on having the most accurate representation in that section of the globe, the section of the globe that is Canada. Another way that you'll see data sliced that municipalities will use is map projections that are specific to one specific range of longitude. Between 2 lines of longitude, and the reason for that is that you can, if you're limiting your data to that slice of the Earth, you can have much more accurate representation between the location on the ground and location on the map. We've all seen the comparison between the Mercator projection and the actual size of land masses on a globe. That kind of distortion is something that we don't want. So different organizations will use different projections in order to get the accuracy they want in their specific geography. So QGIS has suggested something here. What we're doing here is we're basically converting we're converting the Statistics Canada Lambert projection to WGS 84, which is more commonly known as good old latitude and longitude. I'm also not a GIS expert, so if anything I just said was inaccurate, please correct me privately. Don't make me feel bad. I'm pretty sure we're close in there. Okay, so now we've got our nice little map of Canada, and just like any other layer, we've got an attribute table here. So this is the table of data associated with that map of Canada. So you've got, some interesting things like the land area of that that geography, the name. I don't really know. I guess we got the full name, the English name, the French name, and then the abbreviation in each language, and then it's Statistics Canada geographic ID. So some good information there. Like for example, if you want to label the map, you get to use you can use this column to give a nice English label. But what we're going to do is we are actually going to filter this map because we don't care about any province or territory besides Ontario for our data set. They're all great, but for our purposes today, we only care about Ontario. So I'm going to right click on that layer and choose filter. Okay, and we query QGIS in order to, or we use QGIS to query the DBF file in order to filter our data. So in our case, we want the province English name. And then the nice thing is that we can actually get the values of that data over here. Oh, that's what we want. Okay. And I think I have to single quote that. Yeah, that's what we want. There you go. Now we have a nice map of Ontario. Zoom in. There we are. Okay. It doesn't have to be pink. In fact, I think it should be a different color. So I'm going to just show you the QGIS properties page here. So this is the properties of a specific layer. And you can see down the left-hand side, there are a number of different options, a number of different things we can do, including, as I mentioned, joining that data to another layer, so that you could, for example, you might connect a layer of values in order to use those values to color your map. Who won which state? Right? Was it red or was it blue? Well, you could use joins perhaps with a map of the US and a map and a CSV or Excel file of election results. You could use that to create a colored map showing those results. In our case, what we want to do is we want to change the color to something a little bit more cannabis-y. So let's go with a nice green. There we go. Go with a nice. I think that looks like my green right there. Okay. All right. Apply. Click OK. Where's my Ontario? There it is. There's our green province. Okay. Now, have I killed enough time that my geocoding is done? Yeah. Okay. All right. Let's take a look at what GeoAppify did for us here. So you remember there's the original data set. Okay. So here on the left is all the original data in our data set. Here's our latitude and longitude. And here is the GeoAppify formatted address. Okay. In some cases, it got a name. The address gets all chopped up so that you can do different things with it. District, suburb, city, county, state. Okay, lots of stuff. And here's that confidence level I was talking about. Okay, here's one where the GeoAppify is very not convinced, and it's using a data source that I haven't seen before called Who's On First, and that for whatever reason, I don't know if it's because of data quality or what the reason is, but it is not sure that it's got the right address. And yeah, it looks like what they did is they got, you're going to get the center point of the municipality of Port Perry instead of the location of that cannabis store. That's why I love the quality markers, the confidence level indicators in GeoAppify, because it's really hard to figure this out. Like once you've got all these points on a map, and then you'll see it today possibly. What happened the first time I did this is I grabbed this data, I threw it on the map, and we had a cannabis store in the middle of Lake Superior. And that's not right. I'm pretty sure there's no cannabis store there. And that was an indicator that our geocoding went awry. But here's another one. This here we go. The cannabis store in South Australia, Ontario. There's in Illinois. So what we would do in a real world situation, like what you would probably do is sort this sheet by confidence level and start going through your points that have like really crummy confidence and then clean them up. You know, you got to do an assessment. You got to see how bad it is. It's pretty good. There's, you know, there are some lower confidence stuff here. But this is decent. You know, we wouldn't publish a map with this on it, but for the purposes of, you know, the 10 people who are watching this, be warned, some of these points are going to look weird. And I did clean it up, and I do have a cleaned up map that we can look at after. So, so we're going to take this data and we're going to import it into QGIS as a layer. Okay. So we'll add a layer, and in this case, we're now adding a delimited text layer, CSV. Okay, look for our file. It's not that one. There we go. Okay, it's a CSV, so that's good. The delimited text wizard does a pretty good job of guessing what the right fields are. In this case, I think it's got that right. X and Y are long and lat, and it's got the projection and the coordinate reference system right. The coordinate reference system is what would be the specification of that we're using latitude and longitude values, and it looks like it's got that right. And then we've got some sample data down here that we could look at if we wanted to. Okay, looks good. All right, remember I told you that data was dirty. So here we can see that we've got a bunch of outliers. These are all cannabis stores that are mislabeled. That's okay. For our purposes, doesn't matter too much. So here we have a map, and we have cannabis stores as points. The problem is it's not actually a very good map. It's not very illustrative of what we want to see, and I'll show you what I mean. Like, this doesn't do anything for me. Even if I wanted to just know how, like, what's the popularity of cannabis retail? How many stores are there in each geography? This isn't telling us anything. So what we can do is we can visualize this differently on a map. One way that you can visualize dense point data on a map that works really well is a heat map. You can, and QGIS has tooling for creating heat maps. This data is too sparse for a heat map. The map would be mostly white, and we have an awful lot of like individual points, which would be the next, like the lightest shade, right? So your heat map would not really illustrate a whole lot for you. It would probably obscure more than it illustrated. But there is another way that we can do this. So I want to click on properties and then symbology. And so right now we are using a single symbol, but we can also use a point cluster. Okay, and you saw heat map was also an option there. So we can use a point cluster, and what that's going to do is that is going to take nearby points, and it's going to aggregate them and tell you how many points it aggregated. So we're going to 3 millimeters is not good. What I want is map units. Let's say 10. Let's see what that looks like. Whoops, terrible, terrible, not the right choice at all. It looks like we've got 1 or 2 clusters and the rest is all isolated points. So let's try that again. And we're going to cluster that. How did they recommend it? They said 3 millimeters. Let's leave it at 10 and see how that works. Okay. And you'll see that the clustering is dynamic. So the more we zoom in, the more clusters we get. Okay. And we've got tons down here. I think we might have to, there we go. So you got 15 stores in the Windsor area. It looks like we've got, is that Toronto, 108 stores, 34 in Hamilton. Let's zoom in on Toronto. There we go. So now think back to that, think back to the QGIS query. If you wanted to, if we want to take this and zoom in just on Windsor, whoops, the only problem is how hefty the processing is now. It's, it takes a little while to, here we go. There we go. All right, let's zoom in on just Windsor. Okay, so here we have cannabis stores in Windsor, including a couple that are too close together, even on this map to show as individual points. And then if we wanted to, we could bring back that street map. We could bring back that street map and overlay it. You could even put street names on it. And then thinking back to an hour and a half ago when we talked about scenarios, that scenario of which street, which location do I want to put my store becomes something that's really feasible. And if you go back to the pizza mapping episode on our YouTube channel, you can see we also did some analyses, and we were able to identify, you know, what is the average distance between these locations, where is the you know, where is the biggest gap, et cetera, et cetera. Those types of analyses are possible. One of the things that I'll just quickly show you is the processing toolbox. All the different tools that you have to analyze map data. You can do so much with QGIS. If you see a cool map, you see a map, a visualization on a map, and you think, how did they do that? Search Google and ask Google how to do that very same thing in QGIS, and you'll probably come up with a tutorial. You might have to add a plugin or something, but you'll probably come up with a tutorial. QGIS can generate really, really varied and really attractive maps, and again, it doesn't cost anything. So that is everything that I prepared for you folks tonight. So we've looked at data ingestion. We've looked at data manipulation, data cleansing, and a couple of different methods of data manipulation. Every single tool that I use today costs $0. So you can do all of this. All you need is a computer and an internet connection, and all of these tools are out there for you to use, and I highly encourage you to do it. And so that's kind of the end of it. I don't know if we can call this a formal session, but that's the end of the formal part of this session. Does anybody have any questions?
Yes. When you showed what was capable with observable, right?
Yep.
What other people did, I noticed there included map-looking graphs.
Yep.
Have you explored around with what's possible mapping-wise with observable and compared it to QGIS?
So yeah, and let me pull up a map that I've made on observable really quick. And am I still sharing my screen, folks? No, I'm not. So let me do that again. Okay, so what the technology that here's one I did with showing this is sightings of monsters, ghosts, and aliens in Canada. So obviously we need to look at the data. Here we go. All right, so you can, if you can look at this webpage at your leisure and find out all about the ghosts and the aliens. But what we're doing here is we are using Mapbox, which is a JavaScript library for visualizing map data. So Mapbox is supported in Observable. That's one way that you can make a map. Observable Plot also supports generating maps. I think that you can also use other mapping tools as well. So the difference is QGIS is very much a desktop tool, and it's very much about manipulating the map data. So I would use QGIS for two reasons. One would be a quick visualization like we did tonight, something that I'm going to paste into an article or a blog post or something. And the other thing would be for map transformation, for data transformation. QGIS is just like SQL Server is a tool that you can use to manipulate, modify, transform, and join regular data. You can use QGIS for all those things with map data. If all I want to do is visualize, and especially if I want to visualize it for the public, then a tool like Mapbox would be the right tool. So in my professional life, we've built a few map-based applications. We tend to use Leaflet. That would be the tool that we use professionally. It's got a ton of capabilities. It's something that is more appropriate for a high traffic application. If you want something that's going to be reliable in high traffic, and then you probably want to use Leaflet. This is a pretty good system too, and this is great for what we're using it for, which is to make a quick and dirty map. So just for fun here, let's zoom in and see. I think we have one ghost in our area, and it's the Texas Road ghost. So that's the ghost that made it into this data set. I would have to go back in my archives and remember where I found the monsters, UFOs, and ghost data set, but there was a local ghost sighting reported in it, and it's the Texas Road ghost. So there's your Windsor Essex connection. Okay, any other questions? Any questions from online?
I got a question.
Okay.
What's the difference between Canada statistics and census?
The census is a data product of Statistics Canada, but Statistics Canada is a government entity that does a lot of data collection. So if you go to the Statistics Canada webpage, the census is the centerpiece of their data, because that's data that they collect every 10 years on, is it every 10? I think it's every 5 maybe. Every period of years, every 5, I think, they collect data on every Canadian. So it's their premier data set. It contains not just an enumeration of the people and who lives where, but also demographics, probably more demographics than you would expect if you've never looked at a StatsCan data table. But Statistics Canada also does, for example, the labor force survey. So when the newspaper says the unemployment rate in Windsor went up 3% or went down 3%, there's a data product that Statistics Canada produces that generates that number. The labor force survey, you may be interested to know, since I mentioned it, my mean, median, and moose co-panelist Fraser Fathers will always tell you that when you get down to the grain of a local municipality, it's a random number generator because the sample size is so small. That's a national survey. And the sample size in an individual city is so small that's why you'll see the unemployment rate in Windsor swing by, a percentage point from one reporting period to the next. It's because there's a lot of fuzz in those numbers. So Statistics Canada produces a ton of data, and it's really worth going to their website and exploring it. They have a huge amount. I would say other sources of open public data. Statistics Canada is usually my #1 port of call. Every province in Canada, to my knowledge, has an open data portal. Canada has an open data portal. Most major cities have their own open data portal. Windsor has one. Windsor's is pretty good. There's a lot of really interesting information. Okay, Mackenzie asked, what's the difference between ArcGIS and QGIS? They're functionally very similar. ArcGIS is proprietary. It's made by Esri is the name of the company. So if you walked into the GIS department in the city of Windsor, everybody would be using ArcGIS. I did a mapping project a couple of years ago. The University of Windsor was a partner. They were using ArcGIS. Hobbyists will use QGIS. I don't know who else. Like, I don't know who uses QGIS professionally, but it's essentially the open source free alternative to ArcGIS. I don't know if it's a professional tool that people use. Looking at the scale and complexity and capability of that software, I got to believe somebody is using that professionally. But at least in our neck of the woods, everybody that I know of who's a GIS pro would use ArcGIS.
So I had a question. Let's say you wanted to kind of extend this project and you got the opening dates of all those cannabis stores and you wanted to make it into like a timeline so where it would show kind of on a map the dot as you can kind of like over time, like you see those like videos where they have the map and like timeline. So I'm curious, like how could you do that with QGIS and all the?
You can do it with QGIS. You can do time series maps with QGIS. It's not something that I've done before, but it's something I'm eager to do someday. But I know the capability exists. I don't know how easy or hard it is. But maybe that'll be a future border city data event. We'll take a look at time series maps because it's you see a lot of those and they're really attractive and
on YouTube.
Yeah. So it would be a good tool to have. Okay. Any other questions?
We do something about this post.
What's that? Well, so the Texas roast ghost is pretty famous around here, and at least if you're from Amherstburg, which I am, and I remember a night when a few of us friends went out to see the Texas Road Ghost. We went out there at midnight and hung around, but we didn't see anything. But the night was not a total loss because one of the people that I went with is now my wife. So it was a worthwhile expedition, even though we did not see any ghosts. So I encourage you to go out to Texas Road at midnight. Maybe you'll be more successful than I was, but no ghosts in my experience.
Texas Road Ghost?
Yeah. Okay, folks, I'm going to close off the Zoom now. Very much appreciate. We had a pretty good turnout tonight. More folks than I was expecting. So thanks for your interest, and I hope we'll see you all again at a Hackforge event one day.